What if we could measure not just whether AI looks convincing, but whether it actually understands how the world works? In this episode, we dive into three cutting-edge benchmarks that push generative models and agentic coding systems to their limits, from physical reasoning in video generation to long-horizon software upgrades, to human-aligned world state prediction. Together, they reveal a striking gap between surface-level performance and real reasoning, and offer a glimpse of where AI evaluation is headed next. Let's explore the first paper, Figround Benchmarking Physical Reasoning in Generative World Models. Figround reframes physical reasoning evaluation for generative world models by replacing coarse physics scores with a criteria-grounded taxonomy of 13 visually observable laws spanning solid body, mechanics, fluid dynamics, and optics. The benchmark contains 250 text plus image-to-video prompts, each augmented with an explicit expected physical outcome, and 2,000 generated videos from 8 models, including Veo 3, 1, 1, 2, 2, 2, 7, B, A, 1, 4, B, Omni-Weaving, Cosmos, Predict, 2, 514B, 2B, and LTX2, 322B, 219B. Its main novelty is diagnostic granularity. Laws such as gravity, momentum, impenetrability, continuity, reflection, and shadow are scored separately through 2-3 observable subquestions on a 1-5 Likert scale, exposing failures that holistic metrics hide. A large controlled human study with 459 annotators produced 5,796 complete annotations and 37 4K fine-grained labels. After quality control, 352 annotators remained, and split-half model ranking reliability exceeded Spearman's rho equals 0.9. The human results show no model exceeds 3/5 overall, with especially weak solid body reasoning. For example, 1, 2, 2, 2, 7B, A, 1, 4B, and Veo 3, 1 tie at 3.28 overall, but differ sharply with 1, 2, 2 stronger on solid body stability, while Veo 3, 1 leads on fluid and optics by 0.47 and 0.14 points, respectively. To enable reproducible automation, the authors release PhiJudge 9B, an open physics-specialized VLM judge fine-tuned with LoRa on Figround labels. It reduces aggregate relative bias to 3.3% versus 16.6% for Gemini 3, 1 Pro, and far outperforms base Quinn judges whose bias remains above 29%. Let's explore the second paper, Roadmap Bench Evaluating Long-Horizon Agentic Software Development Across Version Upgrades. Roadmap Bench introduces a new benchmark for long-horizon agentic software development by converting real open-source version upgrades into 115 multi-target coding tasks across 17 repositories and 5 languages, with a median Oracle patch of 3,714 lines, changed across 51 files and about 5 subtasks per task. Unlike prior bug fix benchmarks such as SWE Bench Verified, each instance uses a roadmap-style specification that exposes behavioral targets while hiding implementation details. And each subtask has its own weighted test score, so partial progress is measurable via completion score instead of binary pass, fail alone. Evaluating 13 frontier models under open hands, the strongest system, Claude Opus 4.7, resolves only 39.1% of tasks with a 0.692 completion score, while Seed 2.0 Pro reaches 5.2%, showing that multi-file version upgrades remain largely unsolved. The benchmark also diagnoses failure structure. Performance drops monotonically with more files, more changed lines, and higher subtask counts. Strong models fail mostly through implementation-level bugs, while weaker models fail earlier with build errors, missing implementations, and interface mismatches. The authors also validate task quality with static checks, plus rollout-based attribution, repairing confirmed task side defects before release, which makes Roadmap Bench notable not just as a harder benchmark, but as a finer-grained diagnostic of where coding agents break down during realistic software evolution. Let's explore the third paper, World Reason Bench Human-Aligned Stress Testing of Video Generators as Future World State Predictors. World Reason Bench reframes image-to-video evaluation as world state prediction. Given an initial frame and an instruction, can a generator produce a future clip that is physically, socially, logically, and informationally consistent rather than merely photorealistic? The benchmark contains 436 curated cases with 5 to 7 structured QA pairs per case across 4 reasoning dimensions and 22 subcategories, and it is paired with World Reward Bench, a preference set of about 6,000 expert annotated pairs over 1,432 videos from 11 generators. Its key methodological novelty is a 2-part human-aligned evaluation stack. Process-aware reasoning verification separates static outcome accuracy from dynamic process fidelity, while multidimensional quality assessment scores reasoning quality, temporal consistency, and visual aesthetics, with the weighted aggregate SV equals 0.4 steradians plus 0, 3 SC plus 0, 3 SA. On the main benchmark, closed source systems such as Cedence 2, 0, Veo 3, 1, Fast, Kling, WAN 2, 6, and Sora 2 outperform open source models by roughly 2 times on both ScorePR and SV. For example, the best closed model reaches ScorePR 39.8 and SV 594, while open source models range around ScorePR 14.4, 19.6, and SV 2, 1, 338.5. The strongest automatic judge, Quinn 3, 5-27B with the paper's process-aware metric, matches expert human ELO with Spearman Row equals 0.955, exceeding pairwise VLM judge ranking at row equals 0.804. The hardest failure modes are logic reasoning and information-based reasoning, where visually plausible videos often break causal mechanisms or exact text, data preservation, revealing a persistent gap between visual polish and genuine world modeling. That's a wrap on today's AI paper highlights. Thanks for watching.